So when you are factoring, you need to find the prime factors, which are just prime numbers of the number involved in the problem. So just start taking prime number factors out. So you don't have to break down all possible combinations of factors that multiply to 48. Just take out prime numbers. So if you take out a 2, leaving a 24, from 24, you can take out a 2 again, leaving 12. From 12, you can take out a 2 once again, leaving 6. And now from 6, you can take out a 2 and a 3. So that is a factor tree for your prime numbers that form 48. So you take a look at each factor. In this case, you have 2. It appears a total of 4 times. So 2 to the power of 4. And then you have 3. It appears once. And so that would be the prime factorization of 48. If you have a little bit larger number, the same idea holds true. Just start breaking it down. So 3675, you know, ends in a 5. So 5 is a prime factor. And if you divide that through, 5 goes into 36 7 times with 1 remaining, 5 goes into 17 3 times with 2 remaining, and 5 goes into 25 5 times. And continue with that pattern. So 375 or 735 has a common factor of 5, so we remove that. 5 goes into 7 once with 2 remaining. 5 goes into 23 4 times with 3 remaining. 5 goes into 35 7 times. 147 again isn't as common a number, so look to use some of the divisibility rules. If you add up the digits here, 1 plus 4 is 5, plus 7 is 12. 12 is divisible by 3, so that means 3 is a factor of 147. 3 goes into 14 4 times with 2 remaining. 3 goes into 27 9 times. And so 49 can be factored into 7 and 7. So here when you look at your prime factors, if I just go from the smallest number first, I have 1 3. I have 2 5s, so 5 squared, and I have 2 7s, so 7 squared, and that would be your prime factorization. So here, one possible way is to just create a factor tree for each of your numbers. So if we take 42 and we find the prime factors, we have 2 times 21. 21 is 3 times 7. So we have 2, 3, and 7 as factors. And 35 is just 7 and 5. So those are your prime factors. And so you find the ones that they have in common and pull them out. So they both have a 7, so we take the 7 out. And then you have to take out all the remaining ones, so 2, 3, and 5. So this would be your least common multiple. When you multiply these together, 2 times 5 is 10, 7 times 3 is 21, 21 times 10 is 210. Now, the preferred way to do this, or the way I would recommend, would be to set up a chart and use repeated division to find the common factors or common multiples. So if I start with 40 and 48, so here you can just start taking out common factors. It doesn't have to be the prime factors. So between 40 and 48, you might see that 4 is a common factor. 4 divided out of 40 leaves a 10. 4 divided out of 48 leaves a 12. And then you check these numbers again. Are there still any common factors? Yes, there's a common factor of 2. When you take a 2 out of 10, that leaves 5. Take a 2 out of 12, that leaves 6. There's no common factors between 5 and 6, and so these are your factors of the least common multiple. So again, if we take 5 times 2 is 10, 6 times 4 is 240, or 24, 24 times 10 gives us 240 as our least common multiple. Okay, order of operations should be something that you're familiar with. Okay, PEMDAS is the acronym for it. Okay, parentheses are grouping symbols. That's your top priority. Then powers exponents. Second, multiplying and dividing have no priority over each other. It would go from left to right if both are involved. But those are the third priority, and then adding and subtracting would be the fourth priority. Again, neither one has priority over the other, but you will do them last. So when you look at a value like this, 180 divided by 15 divided by 3, okay, since division has the same priority, what you would do is move from left to right. So 180 divided by 15 first. 15 goes into 18 once with 3 remaining. 15 goes into 30 twice. And then 12 divided by 3 gives you 4. And so that would be your answer here. As far as working through parentheses and grouping symbols inside, in this example here, the multiplication of 7 times 4 takes priority. So 7 times the quantity, 4 plus 7 times 4 is 28, minus, and then 3 to the 4th is 81. So that's an exponent. So that's going to happen before I subtract the value. And then it's just a matter of combining in grouping symbols here. 4 plus 28 is 32. 7 times 32, if you take 7 times 30 is 210. 7 times 2 is 14. 210 plus 14 is 224 minus 81, and that gives you your solution here, the simplified form of 143. And when you're being asked to evaluate an expression, to evaluate it, it means to plug in the number for each particular variable and then follow the order of operations for the remaining values. So here, B, I'm going to replace with 6's, Z's, I'm going to replace with 1. So I get 6 squared plus 5 times 6 times 1 plus 1 squared. And now following order of operations, exponents multiply here. So 5 times 6 is 30 times 1 is still 30. 1 squared is 1. And then combine these together. I get 36 plus 30 is 66. Plus 1 is 67. Okay. Now, it may be that you're given expressions but not asked to evaluate numbers for them, just to simplify. If that's the case, you combine all like terms. So here I would distribute my 11. So 8p minus 11 times 4 is 44. Minus minus becomes plus 11p plus 12. And now I can combine my like terms. So 8 plus 11p, 19p, negative 44 plus 12. I take their difference and assign it the value of negatives, so that's 32. Now when you write this, you'll normally write it with the variables written first, but you don't have to. If you had written negative 32 plus 19p, it would accept that, but this would be, again, the preferred form. Okay, for verbal modeling, it's just a matter of representing the words in an expression and math operation form. So if you say that you have S is the number of seniors, and you say that the number of juniors is 3 less than, so I'm subtracting 3 from some number, 2 times the number of seniors, so 2S. So here's the number of juniors representing by those variables. Okay. Quotient is a fraction or ratio. So it's saying the ratio of 5x to the 5th and 2y squared. And so you don't have to simplify anything. Nothing can cancel or simplify. And so that would be your expression.